Factoring by greatest common factor. How is factoring related to multiplying? Well, first of all, we have to remind ourselves about what a factor is. So for example, let's say we had the number 24. Numbers that divide into 24, 6, 4, 8, 3, 2, 12. All of these are possibilities and are numbers that divide into 24. These are considered the factors of 24. But we have to remember that sometimes we talk about prime factorization, and we have used factor trees to have done that in the past. If you remember how to use a factor tree, we can break it all the way down and look at the prime numbers of the tree itself, and we would use that and say that 2 times 2 times 2 times 3, these would be the prime factors of 24. What we're looking at is taking a polynomial and being able to break it down into its prime factors. So I want you to think about factoring like multiplying backwards. That will kind of help us keep things straight. In fact, that's a great way for us to check things. What do I mean by this? Well, let's take, for example, the two monomials, 3 and 2x. If I was to multiply both of them together, I would get 6x. And if I think about factoring, we're going to work backwards. 6x can be broken down into 3 times 2x. So in a way, we can kind of take a look at that. So when we factor polynomials, we look for the largest common factor to pull out. That's the first thing we always do. No matter what, no matter other situations, we're always looking for that GCF. Okay, so let's take a look at this binomial here, 5x to the third plus 10. And here we're going to look at numbers, then we look at variables. 5 and 10. 5 is the greatest common factor, the largest number that goes into both of those numbers. Then we have x to the third, but there are no x's here, so there are nothing in common there. Remember, that's what that GCF means. Greatest, largest, common in both, and a factor can multiply to get there. So we know that if we take 5 and we multiply it times x to the third, 5 times x to the third will give us 5x to the third. 5 times 2 will give us 10. And again, if we were to multiply this back out by distributing, we would come back to where we were in the beginning. So this here is considered the factorization for 5x to the third plus 10. I'm going to try and give you a little bit more of a visual with this problem. 6x to the third plus 12x squared. Now, we can look at numbers that go into 6, such as 3 and 2. So 2 times 3. And I have 3 x's here. 1, 2, 3. The prime factorization for 12 is 2 times 2 times 3. And then I have 2 more x's here. So hopefully this visual will help you think about how we get where we're going. Now, if I look at 6 and 12, hopefully you realize that 6 is the greatest common factor. I can show it in my little diagram here because they both have a 2 in common and they both have a 3 in common. So since they have that in common, we know 6 is what's common. Now we look at the x's. There are 3 x's here and 2 x's there. We can see that they have 2 x's in common. So we're going to pull that to the outside of the parentheses to be 6x squared. Now we think about what gets multiplied to get us back to the beginning. We need one more x because 6x squared times x will get us 6x to the third. And then a positive 2 because 6x squared times 2 will get us 12x squared. You could also take a look at what we've got going on here. See how there's an x left over and a 2 left over. Coincidentally, that's what gets left over inside the parentheses. So this little visual hopefully will help you to see how we choose the numbers we do. Greatest common factor and what gets left behind. Now, one of the really neat things to think about is you can never pull outside more than your lowest number of variables. So because this is x squared, this is x cubed, this is smaller, that's the most that can come out. So that might be another thing to think about. Okay, let's take a look at a couple more. Again, we have 12 u to the third v squared plus 16 uv to the fourth. When we look at 12 and 16, we know that 4 is the greatest common factor there. Here are 3 u's, 1 u, so 1 is the most that can come out. V squared, v to the fourth, v squared is the most that can come out. What got left behind? Well, 4 times 3 is 12. I need 3 u's and 1 is outside, so I would need 2 more. There are already 2 v's on the outside, so I don't need any more for that first term. Going to the second term, 4 times 4 is 16. I already have 1 u outside, don't need another one, but I do need 2 more v's. And this is prime factored. We'll do it again here, and here I want you to notice that both of these, 5m minus 2 minus m times m minus 2, have a binomial in common. Because they have a binomial in common, that's what we're going to pull out. We're going to pull out that m minus 2. And what got left behind, 5 minus m, will be the rest of that prime factorization. Now, what we're going to do is we're going to take a look at one more problem before we jump into some other things. So 18y to the fourth minus 6y to the third plus 12y squared. I have 18, 6, and 12. 6 is the greatest common factor. Then the most I can take out are 2 y's, so we'll pull out 6y squared because they all have a y in common. 6 times 3 is 18. I need 2 more y's, so that becomes y squared. I need a negative 1 here because 6 times negative 1 will give me negative 6, and I need 1 more y. 6 times 2 is 12, and I need no more y's at that point. Now, I also could write this way. I don't necessarily need to have a negative 1 right there. I can just say negative y. So either way is totally acceptable. Well, now let's talk about factoring by grouping. Now, factoring by grouping comes into play when we have 4 terms in the polynomial. So what we're going to do is we're going to follow this little process. We're going to cut the polynomial in half, and then we're going to look on the left side and find the greatest common factor. Then what we'll do is rewrite the binomial that we came up with on the left side. We're automatically going to drop it onto the right side, and then we're going to find the other factor by that way, and then write the 2 binomials down, and those 2 binomials will work. So I'm going to walk you through this one and prove it to you how the steps work. If I cut it in half here, and I took a look at the left side, 2x to the third plus 6x squared, I can pull out a 2 and an x squared. What gets left behind is an x plus 3, because 2x squared times x is 2x to the third, and 2x squared times 3 is 6x squared. I immediately write this x plus 3 down on the other side. In order for this to be factorable, they have to have that binomial in common. And I think 3 times what will give me 3? Well, positive 1 will. And positive 1 times x is x. So just like that previous problem, I'm going to pull out that x plus 3 and leave behind a 2x squared plus 1. And I'm going to prove to you that this works by taking this binomial and multiplying it out. So x times 2x is 2x to the third. X times 1 is x. 3 times 2x squared is 6x squared. And 3 times 1 is 3. If I put this in descending order, we can see that it proves that these are the binomials that factor for this polynomial. So these are the factors of that polynomial. We're going to practice it a couple of times. Here we go. We're going to cut it in half. We're going to look at this 8x squared plus 2x squared. We're going to factor out a 2 and an x squared. Leaves behind a 4, because 2 times 4 is 8, and 1 more x. 2x squared times 1 will give us 2x squared. Immediately write that binomial onto the other side and think 1 times what will give me 3? 3 does. And I write the common binomial down, 4x plus 1, and what gets left behind is 2x squared plus 3. Try it again a couple more times. Cut it in half, look to the left, x cubed plus 3x squared. Here we're going to say we're going to pull out just an x squared. That leaves behind an x plus 3. We write that x plus 3 down, and we'll get that sorry about that. We'll get that plus 2, and then we'll multiply our 2 binomials, x plus 3 times x squared plus 2. And those are our 2 binomials. Let's take a look at this last problem. This one's a little bit more involved. Remember I said about looking for a greatest common factor every time? We can see that a 2 is common here. So we're going to pull that out first, because sometimes, just like we were factoring 24 earlier, we may have a bigger polynomial and it may keep going. So here we're going to split this in half. We're going to take a look at it. So I have 2 on the outside. Here an x squared will factor out, leaving behind an x plus 1. I'm going to write x plus 1 here, and that will give us a negative 4. If I was to write everything down, I'd get that common binomial of x plus 1, and then here's that binomial of x squared minus 4. If you have learned about difference of squares, this will continue. A difference of squares is x minus 2 and x plus 2. And then we would bring everything else down with us, and then this would be the prime factorization for that up polynomial. Hopefully this helps you to realize how to factor by greatest common factor.